Hey there, fellow scientists, and welcome. Today, we're about to jump into something, well, literally, electrifying. We're going to uncover the secrets of circuits and the clever little gadgets that control them. Ready? Let's get started.
So, our whole adventure today kicks off with a mystery. I want you to picture this. You've got a battery, a wire, and a lamp. You hook them all up, expecting light, but you get nothing. The lamp just sits there. What we have here is a classic case of a broken path.
So take a look. We've got our power source, right? The battery, and we have our lamp. But check out the wire. See that? There's a gap. And that's the whole problem. Electricity needs to make a full round-trip journey from the battery through the lamp and all the way back again. And with that gap, it just can't. That little gap is the biggest clue in our mystery. So how do we solve this? To crack this case, you have to understand the number one, most fundamental rule of electricity. It needs a complete road to travel on. I'm telling you, this is the secret to making almost any electrical device work. And that secret has a name. It's called a closed circuit. You know, a really good way to think about it is like a racetrack. Imagine the electricity as a bunch of super fast race cars. For those cars to zoom around and complete a lap, the track can't have any missing pieces, can it? It has to be a perfect, unbroken loop that starts and ends in the same place. It's the exact same idea for our electricity. And there it is, our big aha moment. By closing that gap, we've done it. We've created a closed circuit. The electricity now has its complete racetrack. It can flow all the way around, and boom, our lamp lights up. It really is all about completing the loop. Okay, but let's be real. Connecting and disconnecting a wire with your hands every time you want a light on isn't exactly safe or easy. We need a special tool for this job. So let's meet the hero of our circuit, the clever gap bridger. And that tool is the switch. I mean, this is it. This is our safe, reliable way to control the flow of electricity. You can either complete the circuit to turn something on or break it to turn it right back off. You know, switches are everywhere, and they come in all sorts of shapes and sizes. You've got the classic toggle switch for a light, right? Then there's the push button for a doorbell, and what about that little slide switch on a flashlight? They're all over the place. So how does a switch actually work? Think about an open circuit like a giant canyon with a huge gap. The switch, well, it's like a drawbridge. When you flip it, that bridge comes down, it closes the gap, and it lets all that electricity flow right across, creating that closed circuit we need. Now, it's not just about having a complete path. The actual material that path is made of is incredibly important. It turns out not all materials let electricity flow through them equally well. And this brings us to two main types of materials. You've got your conductors, like metal, which are basically superhighways for electricity. It flows through them so easily. And then you have insulators, like wood or plastic. They're like a giant roadblock. They stop the flow of electricity completely. All right, you've got the knowledge now, so you know what that means. It's time for action. We are turning you from a viewer into an explorer. It is time for your official scientist mission. But wait, before any mission, every good scientist has to follow the code of safety. This is the most important part, so listen up. 1. Never touch switches with wet hands. 2. For your own experiments, please only use battery-powered circuits. And 3. A big one. Never, ever, ever play with the switches or outlets you find in your walls. Okay, ready for your mission? Your task is the switch survey. I want you to go on a hunt around your home and find as many different switches as you can. Identify their type. Is it a slide, a toggle, a push button? You can even keep a tally and see which kind is the most common in your house. Happy hunting, scientists! And as you're exploring, here's one last thing to think about. We learned that a switch is a gap bridger for electricity, but what other kinds of gap bridgers can you find in your world? You know, things that connect stuff that used to be separate. Kind of cool to think about, isn't it? See you next time.